your class and your topic is real numbers and properties. So please write everything that I write. You can write more, but make sure you have what I have down on your notes, okay? So, real numbers, that is our first main idea, and those consist of the following sets of numbers. So quite a bit in here, okay? And we call real numbers R. Sometimes you may see R with 2 lines through it, okay? But that is your symbol for real numbers. And within the real number set, we have quite a bit. We have irrational numbers. Okay, so those are numbers in which the decimal form never terminates. So it never ends and does not repeat. Okay, we'll give even more examples down below, but common examples are pi and non-perfect square roots. Okay? Irrational numbers, we did that, so now we're on rational. Okay, so numbers in which the decimal form either terminates or it repeats. Okay, and within the rational numbers you also have subsets. So there's a lot of numbers you see that are integer, whole, natural, but they're also rational. Okay, rational numbers can be written as a fraction, a over b, where a and b are integers. And that brings us to our next one, integers. Okay, so these are your negative and positive numbers, including 0, that don't have decimals. So for example, -3, -1, -2, then -1, 0, 1, 2, 3. And next to that is whole numbers. So those are your counting numbers and 0. 0, 1, 2, 3, 4. So they're all positive, including 0. And then your smallest set of numbers are the natural numbers. Okay, and those are your counting numbers. Like think about counting on your hand. You start with 1, 2, 3, 4, 5, so on and so forth. Okay? Now, symbols for these, we have, let me make it a little thicker. Okay, rational, those are Q. Then we have integers, Z, whole numbers, W, and natural numbers, N. Oh, and your irrational, those are I. Okay? So let's copy that again down below with your set and your letter. Okay? So irrational numbers, we give an I. Rational numbers, we give a Q. Integers, Z. Whole, W. And natural, N. Okay? And then I'll go on to some examples. So I'm actually going to start from natural and go up. So natural is the most inclusive set of numbers. They are the smallest set of numbers. Okay? So this diagram to the left is going to start with the smallest set of numbers in, and then it goes on and on. But as you go up, notice that n is also included. Okay? So natural numbers, again, were positive, and they don't have a decimal. 10 is a good example. 47. Okay, think about this one, the square root of 9. So even though that doesn't look like a natural, if you take the square root of 9, it's 3, so that is natural. And same idea with something like 34 over 2. So that would end up giving you a natural number. It may not look natural right away, but when you simplify it, it is. Okay, that would be natural. Alright, so whole numbers are basically natural and 0. So very similar to the same set of numbers. Okay, but natural and 0 will be whole. 20 over 4, that's a good example. Okay. Square root of 16, all whole numbers. Alright, let me change my color here. Okay, integers. So those are given as z. I'm not totally sure why, but probably because I is already taken with your rational. But those are z, and those are no decimals, but positive, negative, and 0 are all integers. Okay? So we can have like negative square root of 100. That would be negative 10. Those are zeros, not 6, sorry. 8 over 4. Negative 20 over 10. Okay, some good examples. Alright, and rational Q. Those have decimals that end, so they don't repeat forever, or they can be fractions, and they can also be everything below it too, okay? So they can also be integers, whole numbers, and natural. So like 0.35. Okay, 0.35. Square root of 100. Okay. Repeating decimal, 0.3333 or a third. That just repeats. That's rational because it repeats. It's decimal. Okay. So the decimal either needs to terminate. That would be 0.35. That's a terminating decimal or repeat. Okay, and then if it doesn't terminate or repeat, then we're back up to irrational numbers. Okay, so very common irrational number is pi, as I said, 3.14159, so on and so forth. Alright, think about a square root that you can't simplify to a nice number or a whole number. Square root of 5, okay. Square root of 73. Those would be irrational. Alright, and so irrational is actually outside of the set of everything else, really. Because if you're irrational, think about these circles here. If you're irrational, can you be rational? Can you be an integer? Can you be a whole? No, you can't, okay? But this entire set is still the set of real numbers. Okay, so real numbers include rational and below and irrational. Okay? And we're going to get into what's called imaginary numbers later on. We're just talking about real today. Okay? So, for your next part, and we're not going to do all of these, just a couple so you get what's going on. You need to name all sets to which each value belongs. Okay? So, just for example, if I'm an integer, if that's like the highest set a number is, okay, then notice that you are also a whole number, you are also above it. So you're also a rational number and you're also a real number, okay? And say I'm a natural number, then obviously I'm a whole number, okay? Because I'm just natural and 0 is the set. Then I'm obviously an integer, rational. Remember, I can't be irrational if I'm rational. And then I'm also real. Okay, so keep that in mind. We're going to name all the sets. Alright, negative 10, which we saw already in the examples, but that is an integer if it's negative. Okay, and then think about an integer is also a rational and definitely a real number. Okay. Let's go and do this left column here, and then I may pick a couple from the rest. But, so number 4, we're going to do this column right now. Number 4, 24 over 8, you definitely want to simplify that first before you start naming the sets. So that's 3. Okay, and therefore that's a natural number. So it's actually going to be all of the sets of this diagram here and real. Okay, so we are natural, whole, integer, rational, and real. Okay? Alright, let's look at 7. So pi minus pi is 0. Okay, that is not a natural number, so it's not the same as 4. The smallest set that includes 0 is whole numbers. So that's going to be whole, and then if you're whole, you're an integer. If you're an integer, you're rational. If you're rational, you're real. Okay? Alright, and 109. Think about that for a second. And 109 should be the same thing as 4. We have natural, whole, integer, rational, real. Okay? I just want to do one more that is well, let's do number 8. Okay, and you'll see what it is. So number 8 is the square root of 16 over the square root of 25. Okay, simplify that, and you should know, hopefully, that you can take the square root of the top, which is 4, over the square root of the bottom, which is 5. So that simplifies to 4/5. Okay, so if we have a fraction that is a rational number, but it's not anything else. So if you look at the integers, whole and natural, none of those have fractions or decimals. Okay? So we're really just a rational number here. And if you're rational, you're real. Okay? And the same exact answer is for 9 if you have a repeating decimal. Okay, so that's enough for this page 1, and I'm going to stop the recording. If you need to go back and watch anything over again,